My name is Wayne Macafee. I'm with Penn State Facilities Engineering Institute. We're visiting a client facility today to investigate a steam line rupture that occurred in a manhole. What this will serve to show some of the dangers inherent with steam if certain things are not done the way they should be. Not entirely sure of what mechanism occurred, but we do believe that undrained condensate in the steam line resulting in water hammer was part of the problem. What we're looking at here is the drawing of the steam distribution system for the facility in question. The ruptured valves were located in manhole 21. This section of steam piping is relatively flat, but this is probably the low point because this whole section up to manhole 18 is slope going uphill. There is a high pressure steam trap located in manhole 22. There was not a functioning trap in manhole 21. What we believe happened is that some condensate collected in here, and then one of two things occurred. Either we got enough steam flow and enough water and it picked up a water slug and slammed it into the first valve and caused the bonnet to literally crack and blow off the valve, and then the second valve downstream, the body cracked. The other possibility is that older downstream valve, which we'll look at later, the body cracked, allowed a pressure drop, and the condensate that was there would hot, flashed, and you're literally talking a steam explosion there, and the pressure spike was enough to blow the bonnet off of the other valve. Because we saw no lateral, or we have no signs of lateral displacement in the piping, we believe that the scenario where valve body split led to condensate flashing, a pressure spike, and that blew the bonnet off the other valve is the most likely scenario. We've been discussing and reviewing steam valve failures in a manhole. This particular incident highlights a concern that we do have with the use of cast iron valves in steam systems. The thermal cycling, etc., is hard on them. It's a more brittle than use of steel for steel valves. As you saw from pictures, or you can see that a lot of that older valve was already cracked. You can see where the rust is, and then the black areas are where there was still connection, and that finally split and broke all the way around the body. The only thing holding it together was the bonnet flange. We are recommending that you replace cast iron valves when the opportunity presents itself. When you can, inspect existing cast iron valves and look for any signs of flaws, cracks, other defects, and if warranted, replace the valve. New projects use steel valves. If you're not sure how to identify a cast iron valve versus a steel valve, the stamping on the valve body for cast iron will read 125 or 250 for the pound class, whereas steel valves will be 150, 300, 500 on up, which 150 and 300 are the primary ones that we use in our facilities. While not huge, there is a potential safety issue with those valves failing. If you have any questions about this, feel free to call us here at PSFEI, and we'll be happy to talk to you about it.